Welcome. In this lecture in linear data analysis, which has multiple sessions, we'll explore vector spaces from a different point of view. Previously, we've explored how we can construct a vector space from vectors. Now, we'll ask a different question, which is if we're given a new vector space, what vector in a vector space is closest to that given vector? So we'll call this projecting, and we'll look first at how we can project a vector onto a single vector, which is a one-dimensional space. We'll explore the orthogonal complement. We'll look at the weight vector of a projection, and we'll end by explaining the normal equation for a projection. As we go through this lecture, we can think of a problem, which is how can we approximate a vector? This starts in one dimension, which is suppose that we're given a vector A. So if we're given any non-zero vector, it's a basis for a 1D space, and here it doesn't really matter how many entries A has. What matters is that there's only one vector that's in this space. So now suppose that we're given a new vector C. Now it has to have the same size as A, but let's suppose that it's not a simple multiple. So the question is, what multiple of A is nearest to C? And this immediately restricts us. So we need to have a multiple of A, and we have to have a concept of nearest. Well, we can draw this geometrically. So suppose that we're given this vector A, and then we're presented with a new vector C. Well, what we could do is we could draw a perpendicular line from C down to A, and that would be the vector P, which we'll refer to as the projection. So now, let's see how we could compute this.